Thanks, Pete.
Okay, so let's get going. So what have we been doing for the last while? Basically, the last 7 lessons have been about how do you solve triangles. And when we say solve triangles, we mean solve for unknown sides or unknown angles. And so these are the tools we've learned about. We've learned about the sine rule. When we find sides, we write it like that. When we're trying to find angles, we write it like this. When we're using the cos rule to find sides, we write it like this. When we are using the cos rule to find angles, we write it like that. Generally, depending on what information we are given, that will determine what tool we use to help us solve for an unknown. So there's different bits of information that go with different rules, which we've covered in previous lessons. There's also something called the area rule, which allows us to find the area of a triangle without having the height. But we do still need certain bits of information. We need 2 sides and the included angle for that. Now, in the lesson tonight, there are a couple of other ideas that will probably come up, and I just want to make sure that you are familiar with them. And so sometimes you get situations in questions where we get where that idea comes up. And that's a little bit weird, but what it's saying is that in trigonometry, there's a trig identity which says the sine of 180 minus x is the same as the sine of x. And so I just want to get a sense from the class. Give me a thumbs up if you've seen this reduction formula before. Give me a thumbs down if you've never seen it before. Because as we start to mix the questions together, it's important you kind of have a little bit of a sense of that going on. It's often combined with the fact where we have a triangle and we may have the one side is A, the other side is B, and then the missing angle that's left behind is just going to be 180 minus A plus B. So this one over here would be 180 minus A plus B, because all triangles add up to 180. So I just want to point that out at the beginning of the lesson. The other thing to know is that when we deal with triangles, we also have things like the exterior angle of a triangle theorem. So basically, this one over here, the exterior angle of a triangle, is equal to the sum of the interior opposites. So those 2 over there added together will give you the big green one on the outside. So that's something to bear in mind. And just basic facts about triangles or parallel lines. These types of ideas, so when you have 2 parallel lines and you have that, you may get like these 2 angles are equal. They're called alternate angles. These types of facts will start to be woven into the lesson tonight. And so I'm just pointing out, oh, there's one other one. You also get, there's another reduction formula that says the sine of, say, 90, well, let's say it like this. The cos of 90 minus A is the same as the sine of A. And that's another type of reduction formula that I may mention in reference during the lesson tonight. Now, I don't want to, this isn't, if you haven't done this topic yet, you won't know it, but I'm just pointing it out. So even if you've never heard of it, just let it seep in a little bit, and then we'll see later in the lesson if it comes up. Okay. So let's get going with a question from a past type of exam situation. Okay, here's your question. You are given a diagram that is depicting someone's garden, and you need to calculate the length of the fence that has to go around this garden in order for it to be fenced off. Before you start working this out, I want someone to tell me their strategy, and you can either raise your hand and tell me your strategy, or you can put it in the chat. But what do you think we're going to have to do to answer this question? And then, or what tool do you think we're going to use? And then while we're doing that, Actually, let's just wait for that. Let's just do that first. So what tool do you think we're going to use, and what would your strategy be to find the length of the fence around this triangle? Who has an idea? So sine rule, I absolutely agree, Lutando. And that works because you've got two angles on a side. And so I think what's going to happen is you use the sine rule. And what are you going to use the sine rule to do? What is it going to help you find? Yes, Howard, the length will be the perimeter. So you're quite right. To fence his garden, the length of the fence, it will be the perimeter of the shape going on the outside. So in the chat, we know we need to find the sine rule. What are the actual things we're going to have to find? Yeah, so you're going to have to find KS, and you're also going to have to find MS. So this one and this one. Okay, over to you guys. I want you to find me the perimeter of this shape, bearing in mind that you use the sine rule to help you. Now, you could use the cos rule as well, I suppose, but I think, like we were showing in the last lesson, there's sometimes different ways to do it. But let's just see how you guys go. I'll set you up for the first, actually, no, I think I'm going to let you get going. If you have a question, you can raise your hand in the chat, but I kind of want you to fly a little bit more solo tonight, unless it's your first lesson, in which case, obviously, I understand you're still in the process. So get me an answer for the perimeter of the garden. See what you can get me. Aha. If only we had a value for this angle over here. Maybe in the chat, someone can help me figure out, how do I find the angle S? Because it feels to me like S would be helpful. Yes, Rachel, S is 60. Why is it 60? Yes. Okay, so basically the sum of angles in a triangle. So that's going to be 60. Now that can help me on my journey to finding MS. Yes, Shane, I agree too. Okay, so I then think this will be the sine of 60. So how do we get this MS by itself? That's what we're going for. What is MS going to be? Who would like to tell me their answer, or to put it in the chat? So as I key it in, I essentially have to get, okay, Shane's got an answer that he's given. Oh, Jenna has the same. Yep. Loretta, absolutely. That's looking good. So I'll just confirm. So it does look like the answer is 11,85. Let me just make sure I get the same thing. But then times by the sine of 20. And you should get 11.85. Yes. Okay. So now you've got 11.85. Sorry, guys, my screen just went. That means that this side over here is 11.85. And you have a choice. You now need to find KS. Now you could use the cos rule, or it looks like to me, you could use the sine rule. I don't mind which one. I'm probably going to use the sine rule, but either of them is fine. And I want you to try and find me KS. And then once you found that, I want to know what the final answer, which is the perimeter. Okay.
Mr. Ace,
Yes.
can you please quickly go through how to rearrange the equation when typing the sine rule into the calculator?
So all that you need to do is, in this case, like for KS, the sine of 100 is the thing that's getting in the way. And so we multiply both sides by the sine of 100. And so what we end up getting is 30 sine 100 over sine of 60. And so there's a couple of ways you could do it, but most people would just type it with a fraction button on their calculator. 30 times sine 100 on the top, and then divided by sine of 60 on the bottom. And we should be getting 34.11 as that. And then what is the final answer going to be? So I don't know, Lebo, if that helped, but I think that was the way you would do that.
Thank you, Mr. Ace.
Pleasure. And then the perimeter, if you add all those things together, in fact, I even have the right answers here. I can show you in the perfect working out. You should be getting 75.96. So 75.96. Okay. That's looking good in the chats. I like what I'm seeing. Second part of the question is, how big is the vegetable garden? So I want to know, what tool am I going to use in order to find, so how big is the vegetable garden, basically, is the next question. The answer for the first one was the perimeter of fencing needed was 75.96. Yes. You guys are on it, man. You're quite right. If you want to find the area of the garden, use the area rule. So now it's a question of what are the key pieces of information that we need in order to do this. Now, actually, we have a choice. There's a couple of different ways we could do it. We could use different combinations of sides and angles, but they will all give the same answer. There we go. Oh, Lebo, I see you've got all sorts of interesting pictures you can use. Look at that. You know things about the chat that I could only dream of.
Takes practice.
No, it's like everything. Yeah, it's fun. You can get a gymnast. Where did that come from? Okay, so area rule. And I kind of know the area rule always has this type of shape that looks like this. It's just a question of what goes in. And then what is the value we get for the area of the garden. I think I'm going to focus on that side, and then the angle in between those two sides. So that's what I'm going to use, but you could have used whatever you like. As long as we get the same answer, I'm happy. So I'll put a 30. And then this is going to be 100. And even if you did it differently, the answer will still end up being in the same ballpark. It depends a little bit on the rounding, but for our purposes, okay, so I'm going to go 0.5 times 35 times sine of 100. And we should be getting 175. Now, there's a couple of, it could be 0.5 or 0.1 because the rounding is right on the nose. So both are going to be fine in this context. And that would be, what are the units? It's meters. So it's going to be meters squared. Okay, so there is a little bit of rounding variation, and that is depending on how many decimal places you are carrying. In this case, because it hasn't specified rounding, you're not going to be penalized. Okay, last part of the question. if you are given, if the garden wasn't triangular shaped, if it was rectangular shaped, and one of the width of the garden was 13, how long would the length be? Now, this is actually just a mixing question. Basically, you know how big the garden is. You just worked it out. And they're saying, look, imagine the width is 13. What is the length? I want you guys to use your problem-solving brains, or maybe somebody could come on the line and give us a hint. So the question is saying, if the garden was rectangular shaped, determine the length of the garden if it has a width of 13. And it's going to have the same area as what it had before. Who thinks they know how to work that one out? So for a rectangular garden, your area would be length times breadth, if I remember correctly. Yeah, Bogenka, there we go. So now what is the L going to be? Do you write everything and leave out one bracket? Rachel, that seems like a good idea, yes. So I would say, like, on the one side, basically you have length, so L times 13 equals 175.1, because you know that that's the area of the rectangle. And what you need to find for me is, what is this L? But then using basic equations, you know that I can move that 13 around. So what is my L going to be? So this is like the types of stuff where they combine things. So basically, you're just going to divide both sides by 13. And you should be getting, yeah. So let's go with 1 decimal place. And with 1 decimal place, it will be 13.5. And that will be 13.5 meters. So it's actually quite close to almost a square. Okay, so that was a nice mixture question. Give me a thumbs up if you're feeling okay. Give a thumbs down if you're feeling lost. And then just so I can get a feel for the group, and then also take a screenshot if you need a bit more detail. And then we're going to keep on rolling. Sweet. Okay. Well, here's your next question. And I want you guys to try and do this. All I want is, I want you to post I want you to try and do the first two all by yourself. So in the chat, as you get the answer, just type CD equals or AD equals. But then there will be some of you who feel a bit unsure. And I would love for you to post your question, or I would love for you to just raise your hand and we can have a conversation. Okay, so most of us are, well, a lot of us are trying to find CD, and then we're trying to find AD. And then once we do that, we're putting it in the chat. For those who feel a bit stuck and want to have a conversation about where to go or what approach we should use, you're going to raise your hand and we're going to have a chat, or yeah, let's see how that goes. Because I'm kind of like taking away your safety things and allowing you to try and do it more independently now. But I know some people are going to get stuck here. So I'm really hoping someone will contribute to the class and give us a question or something like that. So let me first look and make sure I know where CD is. It's over here. Oh yeah, it feels like it has a matching thing here. That's good news. And then it feels like this one over here has a matching. Oh wait, no, but I don't know what that one is yet. Oh, but I don't need that one. What am I doing? I actually probably going to need this one over here. Yeah. And so I can use the sine rule to help me find CD like that. Yeah. Okay. So what we're seeing is that we should get 59.13 as our meters. Let me just quickly check to make sure. I'm pretty sure 59.13. Yep, that's it. Now, what is AD going to be? And what tool are we going to use? Rachel, good question. Okay, so let's just first fill this in. So CD is 59.13. So we know what that is. Now, I suspect Rachel is asking me about the cos rule because she wants to use the cos rule in this next bit here. Now, let's just check we have all the raw materials. We have two sides of the included angle. So what we do when we want to find a side using the cos rule is we start by writing AD squared. So we write AD squared is equal to. And then what we have is we have one of the sides squared, another one of the sides squared, minus 2, and then there's two spaces there. And then there's the cos of the angle in between that. Does that help a little bit, Rachel, in terms of remembering that structure? Okay, so if we look at the second question, or looking at finding AD, we actually couldn't use the sine rule there because we don't have a matching angle side pair. Would it be wrong if I said angle D equals angle B? I'm afraid it would be wrong, Bongeka, because you don't know that there's parallel lines. If the lines were parallel, you would then know that. But because you don't, in this scenario, it doesn't really help you there. So at the moment, what we're trying to do is we're trying to find this bit here. And what I was saying is AD squared, if I'm using the cos rule, I'm going to use the other two sides to be filled in. So 52, 74, 52, 74, and then this is going to be the angle in between them is the 36. A lot of my earlier videos really go into getting used to the way of writing it out. That's why I can do it so fast, because I know that if I'm finding the third side, I use the other two sides in the formula and the angle in between those two sides. So what are we getting for AD as our answer? It's okay. I'm going to show you the answer in the moment for the whole question, and then you can check where you went wrong there. Because, yeah, let me just quickly, 59.13. You probably just made a little error there. Okay, so what we find with AD is we get 44.2. So this is 44.2. Let me actually give you this whole answer here quickly. And then you can actually look at it. Let me just hide that away. Don't want to give the answer away for the last question. Okay, so let's just check that everyone is on the right track here. That is how we got the answer for 6.1 and 6.2. Now, for this final step, you need to find me the area of ABCD. And to find the area of ABCD, you're going to find the area of two triangles. But there's one key bit of information we need to figure out. And we haven't figured it out yet. What's the one missing piece of information we need in order to do 6.3? I want to see it in the chat. Oh, I'd love to hear your voice. BC, you don't need BC. I mean, it's something which we don't have. But when I was thinking of finding the area of ABCD, I was thinking of using the area rule. And I felt like in this triangle, I was all good, but there was something missing in that triangle. Yes, Rachel, you can add the two triangles together to find the area of the whole thing. But I got a bit stuck in the second triangle, it was like I was missing something. Isake, yes, I'm missing angle D. Who knows what angle D is going to be? How are we going to work that out? Okay, so because all angles add up to 40, I mean, sorry, not 40, 180, this is going to be 40. And so we could say angle D is 40 because sum of angles in triangle. Okay, this is good news because in order to use the area rule, I need two sides and the included angle. And I now see that I have these two sides and the included angle. And then for this one, I have these two sides and the included angle. So find me what my area is for the whole shape. That is what I want to know from you guys. What is the area of the whole shape? And you basically have to find the area of one triangle, find the area of the other, and then add them together. So think about how the area rule is written out. So it's always going to have this structure, half sine of some angle, and then they're also going to do that for the other triangle, which is that, and that. It feels to me like 74, 52, that would be 36. Then here it would be, oh, you can kind of see where I'm going. That's going to be 52, 59.13. And then this is going to be 40. So what is my final answer going to be? And we should be getting, according to the answer book, 2119.11 meters squared. So it should be this one down here. Okay. Now, there will be, sometimes if there's a decimal rounding, there might be a slight variation, but you should be in that ballpark, and it should be meters squared. All right. Give us a thumbs up if you're feeling good. Give us a thumbs down if you're feeling very lost, just so we can get a sense of the group, as it is a little bit quiet in here today. And so I need to get a feel for my class. Awesome. Awesome, awesome, awesome. Okay, you know what we need to do? We need to invest in ourselves, everyone. And so what we're going to do is we're going to turn on our cameras and we are going to stand up and we are going to stretch just to get our brains a little bit of oxygen. And so Lebo, if you could please tell me which students are doing their best stretch. Well, get some life back into my legs and arms. Oh. Nizolia, I know you want to stretch. Come on. David, Muzi, you're born to stretch. Let's do it.
We have David joining in.
There we go. Yeah, boy. Yeah, boy. Let's go.
Come on, guys. Join in on the stretch.
I promise you, you think you don't want to, and then you start doing it. And you're like, oh my goodness, best I made all day.
Yes. Manuel, Andile.
All righty. Oh, I can't tell you guys, if you haven't stretched, you've missed out. You must be having serious FOMO right now, because I feel like $1 million. Oh, so
rejuvenated.
Good. I do. I'm not even making this up. Like, okay, brain break time. Tell me about how much is the giraffe worth to you? Over to you guys. Tell me what a giraffe is worth. And then, next time I must bring my giraffe picture. Let's see if I can scratch it up somewhere. I think you're on the right track, Rachel, but how much is the giraffe worth to you? That's what I want to know. Aha, yes. Okay. So it's going to be 4 plus 4 plus 4 plus 4 for those ones. And then if you think about it, I mean, there's different ways of doing it, but basically this ends up being 13. And, oh, sorry, that's 13 because 13 plus 3 is 6. 6 divided by, sorry, 13 plus 3 is 16. Divided by 2 is 8. 4 times 2 is 8. So this has to be 13. Yes, well done, everyone. It wasn't too hard today because I knew that the lesson, I was going to stretch your brains. And so I thought I would just be funny as opposed to being too hard. All right, so let's do another one. Little all exam question. And I want to start by getting you to find me SQ. And then once we've found SQ, we'll have a little bit of a chat. But for those who are feeling generous, pop it in the chat what tool you think you would use to find SQ. Yes, it's going to be the cos rule. Because you can see those two sides and the included angle. Now the challenge is, can you write it out without looking at the formula sheet? Yes, Loretta. Yes, Boitomero. Isake, you guys have got it. Can you write out the rule without having to go back to the formula sheet? That is where your next level of learning lies. When you get that freedom, suddenly the section becomes easy because you have those formulas in your head. You just bring them out when you see the situation. Oh, sorry, guys. My mouse got away from me. So QS or S squared is equal to 10 squared plus 7 squared minus 2, 10 times 7 times the cos of 63. So what is QS going to be equal to? It is equal to 9.24. Yes. Okay, awesome. So we've got this one and it's 9.24. Now it's time for a bit of a discussion because the next question is worth 6 marks. So now I need to find PS. And I would love an idea or a comment from the class as to, because this is clearly going to be more than one step. What are some of the things that you think might become helpful as we try to find what PS is? So look at the drawing and then pop your hand up and I'll let you give your comment or put it in the chat. What do you think might help us as we try and find the value of PS, the length PS? Okay, Nolotando, let's go to you. Nolotando, what do you think might be important?
Hi, sir. I think what would be important is that PQ is parallel to SR.
Ah, yes, there's parallel lines in play. How could you use those parallel lines? What do you know about parallel lines that maybe you could help us?
We could use alternating angles where angle R is equals to angle Q.
Okay, but that's not quite. You're on the right ballpark, but R and Q, they're, oh, I see what you mean. So you can work out the whole of that over here because they're between parallel lines. I see that bit. I was thinking, what do you think the relationship is between this angle down here? Like, what do you think that would be equal to? Are you seeing my angle down there?
Yes, I don't know.
Okay. Have you heard of something called alternate angles?
Yes, sir.
So would you agree with me that this angle over here is equal to this angle up here because of the Z shape?
Oh, yes, sir.
Okay, but the problem I have, maybe someone else can help me or you can help me, is I don't know how to find, I'll call it angle S or angle RSQ. The problem is what I'm looking for, PS, is in the other triangle, and now I'm stuck referring to this triangle. And I'm just wondering if maybe someone else could help me. But thank you, Nalatando. You've already helped me a lot.
You're welcome, sir.
I need to find S. Who has an idea? So you have two choices, actually. You could use the cos rule or the sine rule. Either of them are fine, but you really need to find out what this angle is down here, I think. Because once you find out what that angle is, you can work out what this angle is. And then, if you know that, I suspect you may also know something else. Okay, but let's try and get this angle S here. Let's try and get that one. Now it's worth 6 marks, so you know it's going to be a bit of work. I think I'm going to use the cos rule, although a lot of you would use the sine rule, and both are completely fine. But because I have all three sides, I was thinking the cos of RSQ is equal to, and we know we have this fraction thing. And then we're going to have and a lot of students haven't quite figured out how to write this, but I know it's going to kind of look something like that. And then this is going to be 10 squared, 9.24 squared, 10, 9.24. And then we can get the angle. Or we could also get it by going the sine of QSR over 7 is equal to the sine of 63 over 9.24. Is that what, yeah, 7 opposite that? Yeah. So both of those ways could get us to the final answer. It's just a question of which one you prefer. Now, I'm going to give you some time to try and work out what that value is. I'm going to get rid of some that's working at the bottom. And I just want to confirm that, but even if you use the sine rule or the cos rule, you should be getting the same answer. Maybe in the chat, you can tell us, like, if you notice someone who, okay, let me just, so I get lots of 42.45s, and you're quite right, it is 42.45. I just like a look at the answer there. So we know it's going to be 42.45 degrees, which means this is 42.45, and which means that this one over here is 42.45. Now, using the fact that we haven't spoken about these two up here, what are these two telling us about? This means it's an isosceles triangle, which means that the base angles will be equal. Okay, now I'm getting somewhere, because it feels like, if I know that's 42.45 and that's 42.45, what is P going to be equal to? That's what I want to know. So what is angle P going to be equal to? So this is a little bit harder, but you can see how we... So I think that we need to go 180 minus the two triangles that are in the... So 42.45 minus 42.5. And you should be getting 95.1. Now, I'm going to show you the perfect model answer in a moment. But for now, I'm just showing you the process. Okay, finally, we're getting there. We've done a lot of work here. Now, we should have to write down reasons as we go and stuff, but let's just try and get this done. We wanted to find PS. What are we going to use to find PS at the very end now? We've got the information on the screen. What tool should I use? And then I want you to use that tool. I don't know if I would use the cos rule. The reason is I don't have the length of this side here, and I don't have the length. So I don't have two sides of the included angle. I think it's the sine rule. And I'm going to start by writing PS over something. And I'm going to go, what's opposite side PS? And it's going to be the sine of 42.45. And then I want to know what is going to be on the other side. Maybe you can write it in the chat for me. What is going to be on the other side here? So I need a matching pair of angles and sides. It looks to me like 9.24 would be the side. And then below that is going to be the sine of 95.1, because that's opposite the 9.24. And so what is my final answer for PS? That was quite a question. But I did promise you exam, or not exam, but kind of going down that. Let me actually move up a little bit. So that was the first part. That's what we should be getting. I'll zoom out a little bit. So the final answer should be around 6.26. And I hope that you can see everything on the screen. Notice how I do give reasons for my statements. So you can see there's the alternate angles, there's that. But basically your final answer is going to be 6.26. Now, we're almost done with this question. The final part of this question is, I want you to find me the area of this entire quadrilateral. So you figured out that this bit over here is 6.26. I want you to find me the area of this entire quadrilateral. And I think you know what tool you're going to use. If you want to find area, you need to use the area rule. But how do you use the area rule on a shape like a quadrilateral? We kind of did a question like this earlier. I want you to think about it. What do we need? What do we have? Etc. So I see lots of people some people working. I think we just find the area of each triangle. And so I just need to make sure again that I've got the right information for the job. I'll give a little bit more time, and just when you're ready, you can put your answer in the chat. So I think over here, look, we've got 6.26, and then we've got 9.24. And then between those, we've got 42.45. So the good news is the more you do of these, the more predictable they become. Let's just see if I can bring that up for you. It looks like an absolute mouthful. You should have got around 50.71. So it should look something like that. Okay, now well done, everyone, if you survived that question, because that was a proper interrelated. There was no more just using the cos rule, just using the sine rule. We used pretty much every rule in a number of ways there. And so I just want to ask, are there any questions from the class? Or if you're feeling okay, give a thumbs up. If you're feeling a bit lost, give us a thumbs down. I'm going to try one more question tonight, and then I think we're going to call it a day. But, you know, we are now properly getting to the sort of exam type questions. Now, for those who are feeling maybe a little bit overwhelmed, remember, it may be that you haven't seen some of the earlier lessons. If you go back and look at some of those earlier lessons where we look at just the cos rule, we spend like one whole lesson just looking at the cos rule to find sides. 95.1. Yeah. So, all right, cool. Let's keep on rolling. Let's finish with this question tonight. So I'm going to ask for hints in the chat from those who are willing to give hints. What approach are you going to use? Otherwise, if you're comfortable starting, you're given a radio mast and it's supported by 2 cable ties. You're given the lengths and you need to find this angle over here is what it's asking for. What tool do you think you're going to use to find that angle there? And take a moment to look through it. And I want us to almost have a little chat about it. What do you actually have that fits the job? So Bongeka, I'm with you because there's a 90-degree angle there, but then I looked around and I went, I only have one side. I only have the 11 in that right angle triangle. So then I was thinking, what other tool might work well here to find CAB? Just take a moment to read through and look and ask, what information have you got that maybe could be helpful? So as I look at the triangle, it seems to me like I've got one side, I've got this side, and I've got that side. And when I have 3 sides, I'm pretty sure I can use the cos rule to find any angle in this triangle. So let's try and use the cos rule where we write it up in terms of, we'll start by writing the cos of angle CAB. It's going to be equal to a fraction. And I want to see, do you know what's on each side? Like I always say to students, look at the side that's opposite the angle you want. And you write that. And then the rest of it is just going to be using the other sides that you haven't used. So you've used 8, it was the -1. What are the 2 that are left? It's just these 2. So you go 10 squared plus 11 squared, and that's 10 times 11. Now, what is the angle going to be? Remembering that you need to go shift cos of this whole value, or inverse cos of this whole value. Kakeko, I'm gonna, you'll see in previous lessons, we do have it up. Otherwise, there was something at the beginning of the lesson. Let me see if I can go and find it for you. Where was it? Let me just grab this thing. I'll pop it down here. So for those who are feeling a little bit overwhelmed by formulas and stuff, here is a, let me zoom in again. Go like that. Okay, what's my angle going to be? Yeah, so it's going to be in the region of 44.46, 44.47. Okay, so that is going to be it depends on how many. Let me have a quick look, see what I get exactly. So, 8 squared over. Okay, 44 point. Go with that, 47. And then if we get that, determine the height. Okay, so let's go with this angle being 44.47. Okay, now if we, and you could have used 44.46, it just depends on the rounding in this case. In fact, let's just go with 44.5. We'll go to one decimal place. That way it'll just be, so we'll call this 44.5. We now want to find the mast CP. Okay, which is this one up here. How are we going to find this mast up here? What rule could we use to find the mast? There's actually two ways we could find the mast. I think I'm going to use the sine rule though. Yeah, I think the sine rule will be quicker. You can use normal trigonometry. You could say like this is O, this is H, this is A. That would work, but the sine rule works for everything. And so what I would do is I would just say CP divided by the sine of 44.5 is equal to 11 over the sine of 90. And then what is my CP value going to be equal to? Okay, so we should get, again, using one decimal place, we should be getting 7.7. So this is going to be 7.7. All right, last bit. Last question of the day. If that's 7.7, we need to now find the area of triangle CAB. What is the area of triangle CAB? Oh, this doesn't look too difficult because I know what BA is, I know what AC is, and I know the angle that is between those two. And so what is my area of this triangle going to be? And then, guys, I've pushed you hard today. We are going to call it a night. A half, something, something, something. So we want to find the area of this whole triangle CAB. And it looks like it to me that one of these is going to be 10. Another one is going to be 11. And then this is going to be 44.5. So what is my final area going to be? So you should get 38.55 meters squared. Come on, we can do it. There we go, 38.55. So I see a question while I take this question level, if you could please put the link to the quiz in the chat, because I know some students will be ready to take the quiz now, and then I'm just going to answer what questions I can in the time that's remaining. Okay, Mamantle,
Okay.
can I answer your question? What is your question? Or maybe your hand just went up by mistake. I'm not sure, but I'm asking you to unmute. Ah, good question. Would it be wrong to use the normal area method? Oh, you know what, Mamantle, you're so right. If you look at the triangle, we have the perpendicular height, it's 7.7. We have the base, which is 10. We could just go a half was 10 times 7.7. And then we should be getting, wait, yeah, half that. You should be getting the same answer. Yeah. So half 10 times 7.7, and you should get the same final answer. Well spotted, man. That was really good. Oretile, what's your question?
Hi, sir. I have a question about 3.2.
Okay, go ahead.
So I decided to use the cos rule to find the length of CP, and I got my final answer as 8.
Okay, so you used, okay, here's the problem. You don't, in order to use the cos rule, you would have had to have had the length of this side over here. Can you see that?
Okay.
You
Yes, sir.
used the 10, but the 10 goes too far.
Okay, sir.
That was
I see it. Thank you.
Good question. Good question.
Okay.
All right. All right. So Lesego, I haven't covered the proof in this module because I think it's something which you basically can learn by looking at the drawing. So we aren't going to cover it explicitly, but you can basically look it up per se. Also, the proof doesn't generally get asked that much. And so I've made the decision that because of the limited time, I haven't covered it in this area. Okay. But generally, if you want, in question time in another module, you can ask me about the proof and I'll go through it in a bit more detail. Just because of limited time, I felt like the time we could spend would be better spent on questions.